compel industry adoption and increase visibility and opportunity for RISC-V within and beyond RISC-V International. Prior to RISC-V International, Calista held a variety of roles at IBM, including Vice President of IBM Z ecosystem, where she led strategic relationship across software vendors, system integrators, business partners, and developer communities. While at IBM, she also drove numerous acquisition and divestiture missions and several strategic alliances. Prior to IBM, she was an entrepreneur in several successful startups in the IT industry. Calista holds degrees from the University of Michigan and Northwestern University. So, ladies and gentlemen, without further ado, please welcome Calista Redmond.
Thank you for having me. I assume that my prepared remarks are also ready for
yes. Alex, can you help with that?
I cannot present them from the car today, sorry.
That's okay. So we are ready. Yeah, Alex, go ahead.
Hi, I'm Calista Redmond, CEO of RISC-V International, and I'm here today to share with you the rich opportunity, the incredible progress, and the amazing collaboration that we're seeing across the RISC-V community around the world. Thank you for having me, and I'm excited to have this discussion with you. First of all, open source has been around for quite a long time, several decades if you look at the software history. But truly, that open collaboration and that spirit of collaboration for the greater good has been around for about 100 years, since the dawn of the standards and global standards in England so many years ago. That renaissance of open source collaboration, that ideology that together we can build those base building blocks is now full speed ahead in open hardware. And we're excited to be at the very foundation of that as a base ISA. RISC-V is the free and open source instruction set architecture. It is driven through open collaboration. This is something that was derived through lots of collaboration over the last 10 years, initiated at Berkeley many years ago, and 5 years ago we formed the RISC-V community as a foundation, and now as RISC-V International. RISC-V is absolutely the foundation for open computing, and we have ushered in an incredible new era, and that is something that each of us can participate in, whether at the hardware level or the software stack that rides on top of it. This has enabled so much innovation and a renaissance not only for large multinationals, but for entrepreneurs as well. The barriers of entry have come down, and the opportunity for innovation and new markets and new opportunities has skyrocketed. Why is this? First, let's think about the technology. At a base level, the RISC-V ISA is really quite small and compact. 47 base instructions is the core of the RISC-V ISA. On this, you can then add the extensions and aspects that you need for your specific implementation. This is a far different approach from the more incremental add-on-to approach that you see in legacy ISAs, which can often come with a base ISA of 1,500 base instructions. This means that the RISC-V ISA is much more modular by design and brings with it much fewer instructions that you need to grapple with. That allows for much more creativity and design, and generally speaking, we're finding a lower power consumption without the compromise of performance. This has also brought design flexibility. So once upon a time, the equation was price performance, right? We started to look at this with Moore's law. The next dimension that has entered this paradigm is design flexibility. Where are the boundaries upon which you need to operate? Well, there are no boundaries. In fact, the only constraints are the design and the implementation that you're seeking to deliver. So if you're seeking to morph from a wearable into an embedded device of another kind, you have that design freedom to do that without needing to go back and renegotiate exactly where those boundaries are. This has caused an increase in innovation and something we're very excited about. All of this innovation leads to more opportunity, richer opportunity. And at a business level, it's not just about the money you save or the money you can make, but it's also about the freedom to work with whomever you like. And that is what underpins open source collaboration. You can collaborate around the world with leading experts, and you can shift and morph with the type of construct that works best for your business model. That enables a lot of development and design freedom. This also allows you to broaden your supply chain options. You no longer have the constraints of lock-in to one supplier or one geography. You're free and able to operate much more openly. So what comes into the product also grows your opportunity on where you can take your product. And that product opportunity expands your geographic reach, it expands your industry reach, and it expands your ability to progress those opportunities at a much more accelerated pace. You no longer need to wait a couple, 2 to 3 years to renegotiate a design contract or a licensing contract or a royalties contract. You can go and embark on that next new mission, that greenfield opportunity immediately. So beyond removing barriers and collaboration, what are those new opportunities and how fast are they growing? Now, I'm about to show you a bunch of charts that have a very similar picture. The opportunity is skyrocketing, and it is yours to seize. So here's the first one. 50 billion connected and IoT devices in the next few years. That's the prediction by 2025. If you look at this chart, you see 2021 on that chart, that's where we are today. And we are continuing to progress along that continuum. Enterprise IoT is very strong in this space. Smartphones continue to be a very strong area for growth. And we're starting to see smart home devices come in, wearables, and tablets and other consumer devices as part of the connected and IoT devices paradigm. So where does RISC-V fall in this overall opportunity? Well, it's not just IoT. It's the OEMs that are beginning to integrate their own custom designs. Because the barriers of entry have come down and the barriers of ongoing participation have come down, licensing fees, royalty fees, foundries, relationships with supply chains, the volumes and other development that needs to go into custom designs, it is much more appealing not only for entrepreneurs, but multinationals as well. So where 30% were designing their own ASICs before, that is skyrocketing to 40%, which is quite an increase. So RISC-V is participating in this paradigm. I love this chart. When Semico first put out this study, this number, how many billion cores by 2025, was 62 billion. Well, they've gone back to the numbers. They've gone back to the folks participating in this space. We've recalculated and said, you know what? It's actually 80 billion. And truth be told, I still think these numbers are low. You find RISC-V microcontrollers and cores in many products today that aren't even reported. When you go to buy some cookies, you don't ask, what brand is the baking soda? You ask, does this satisfy my need before you start to dig into the underlying architecture. It's the same thing when you buy a car. You don't ask, I know there's a lot of computers in here. How many different architectures are you using, and are you using RISC-V? RISC-V is already part of many of the things you're buying today. So I expect that these numbers will continue to grow and to show that prevalence of RISC-V across many different domains and across many different geographies. But let's just take the value of this information. By 2025, over 14% of the overall CPU core business will be RISC-V. This is already happening. We're already seeing this. In fact, Counterpoint Research, just in the last month, has said by 2025, RISC-V is going to be 28%, nearly a third of IoT. It's going to be 12% of industrial and 10% of automotive. We are finding and infusing RISC-V under the covers and under the hood across many different industries. This is really because, the opportunity overall is growing, going from 5.2 billion to 8.6 billion. And RISC-V has so many advantages, so many inherent advantages, from design flexibility to cost dimensions to accelerated development based on those modular building blocks, that it is much more appealing to start and grow those strategic initiatives on RISC-V. So where are we today? Well, just last November, Wilson Research Group and Siemens found that 23%, nearly a quarter of ASICs and FPGA design starts incorporated RISC-V in at least one processor. This is an incredible progress. Considering our community came together only 5 years ago, and now we're seeing nearly a quarter of designs including RISC-V, this is incredible growth. In fact, no microprocessor has grown this fast since the mid-'80s, which was kind of the last time we had a processor war. RISC-V is not at war. RISC-V is the open solution that brings us together, that allows us to collaborate, that allows us to move forward and progress the state of the art. Let's use shared building blocks and then put your differentiation on top of and around that. It's not just the IP, although the IP is growing very fast, 54.1% CAGR, growing to $1 billion industry by 2025. This is why there are now more design houses on RISC-V than any other architecture in history. It's not just the IP, though. Software and tools is growing at an incredible clip as well. And that is the surrounding community that is essential to gaining global momentum for RISC-V. And we are seeing it. We are seeing it across many different industries, and I'll walk you through just a few of those in a minute. But from data center to embedded, from enterprise to embedded, from HPC and the biggest scale-out workloads to the smallest embedded devices, we are seeing RISC-V. So data center, cloud, HPC, I'm kind of starting to run out of room on these charts. But Intel has now revealed their Neos processor. This is based on the RV32 specification, and this is designed for performance. So Intel's in the boat. Alibaba, they have been a huge supporter of RISC-V as one of our premier members, and their Huanxi 910 processor has been used in cloud and edge specifically around acceleration. And they have also shared with the world roadmaps incorporating RISC-V as a key element of their strategy. Imagination has brought out an entire CPU family. Seagate, very essential in the data center and elsewhere for hard disk controllers, and as they move from memory into disk controllers. On the HPC front, Europe has really taken a strong lead with the European Processor Initiative. In fact, just in September, they had the tape out of their first chip. And Technical University of Munich has started to work with RISC-V for quantum cryptography. And this is absolutely essential as we embark on security. Now, let me just pause there for a second. Transparency underlies security. So without transparency, you cannot be ensured of security. And that is something that we have been realizing with open source for decades now. And it is as true in the hardware as it is in the software. Tactical Computing Labs, another big supporter for us in HPC, has put together a HPC-centric software test suite. And we are now beginning to port many of the math libraries and other things to RISC-V to truly enable a revolution in HPC on RISC-V. Let's keep going. Telecom and communications with 5G, we have tremendous opportunity from handsets to other connected devices. Andes has been at a leading edge of this with their 64-bit RISC-V processor, and this has been adopted by SK Telecom in South Korea. Alibaba also has ported the Android 10 onto its own in-house 64-bit RISC-V core. And this has been emulated as well. And we are continuing to see huge interest in Android on RISC-V and are continuing to work on this in our community. In fact, we even have an Android special interest group because there is so much growing interest within our community. If you're interested in Android on RISC-V, I hope you'll join us. In automotive, where safety and security are absolutely critical. Imagination Technologies has a GPU that has been connected for safety critical certifications for automotive. IAR Systems also engaged here with their 32-bit RISC-V core that they have worked on together with a subsidiary of Denso, as well as software together with NVIDIA. We're seeing this with Renesas and Sci-Fi jointly developing next-generation RISC-V solutions specific to automotive. And in Europe, the GA Next project around power converters is leveraging RISC-V as well. And this is so important as we look at electric vehicle charging systems that are being used and rolled out globally. Consumer and IoT devices. We're seeing a bunch of success here too. It's amazing. Huawei unveiled its Hi3861 from HiSilicon RISC-V board for Harmony OS developers, and this is very targeted to the IoT market. Zepp Health, formerly known as Swami, has been a wearable manufacturer, and they also have OS supporting the RISC-V reference models for the RISC-V P extension specifically, and they've been doing RISC-V wearables for several years now. GreenWaves has been engaged very deeply in hearables. So the little buds that help to pick up those Bluetooth signals from your phone, from your device, they're being rolled out in the millions each month. Microchip has been at the forefront of low power implementations and has an FPGA development kit geared specifically for RISC-V. In China, the RIOS Lab, a collaboration between Tsinghua University and Berkeley, has the Pico Rio. This is the most affordable RISC-V open source small board computer so that everyone can start to progress and innovate on RISC-V. And Sci-Fi, the world's fastest development board for personal computers. And we're seeing more RISC-V personal computers coming out in the planning stages, especially in China. AI and ML. This is another part of what I would call the Moore's Law, like kind of afterthought, right? If you can't shrink things because physics gets in the way, how can we speed them up? How can we offload compute? How can we use virtualization? How can we compute at the edge rather than at the primary processor? AI and ML is one of those differentiators, and you see this coming out across the field from cloud data centers to discrete applications to HPC. AI and ML is at the edge and all the way back to the data center. So where we can optimize and crunch that data, we are absolutely keen to do so. Esperanto, 1,000 core RISC-V AI accelerator, Star5, RISC-V AI visual processing platform. So this is Star5 is one of the leading growth companies in China for us. Andes has been involved in this for about a decade now, and they have released a superscalar multi-core and L2 cache controller processor. NVIDIA, the CUDA support on the Vortex RISC-V GPU is bringing RISC-V directly into the GPU space. This scales from 1 to 32 core GPU based on the RV32 spec and brings OpenCL 1.2 graphics API support. This is a very strong undercurrent that you're seeing to bring not only RISC-V as an open standard in, but also to leverage the other open pieces of the community as well. So we work hard at RISC-V to lever our alliances and to build traction across the industries. Edge computing. You can see several examples here where computing at the edge reduces the need to bring workloads back to the primary processors. We're seeing this with Micromagic and their 64-bit RISC-V core with 5 gigahertz and 13,000 core marks. Western Digital, their Swerve core, enabling spectrum of compute at the edge. It is our dedicated community. It is every stakeholder in our community that matters, that we work together with, from services at fab and design levels to I/O, memory storage, interconnect, to the chip IP providers, from universities and other training practitioners who are helping to build RISC-V talent and growth opportunities across the spectrum of need, across very specific industries. We measure our growth and our traction from mobile to HPC, machine learning, automotive, and AI. But it's all of us. It's the press and analysts who are measuring the progress and reporting on the latest in RISC-V, the individual advocates and students and designers and investors. There are VC firms dedicated to RISC-V. That's how fast we're growing. In fact, you look at this chart, and it's another skyrocketing chart. We now have more than 2,300 members in RISC-V spread across 70 different countries, and we more than doubled in 2020. A year that most were kind of saddled with a pandemic, we grew 133%, and in 2021, we've already more than doubled. This is tremendous growth for RISC-V, but importantly, it's showing that we have crossed the chasm. We are no longer in the early adopter phase. This is prime time. This is mainstream, and RISC-V is here as the foundation for the open era of computing, and we are going to be here for decades to come. And I say that because there is no longer a reliance on one stakeholder or one company. It is an entire ecosystem that is investing and growing and building together. So what does RISC-V International do? We are here to support the profound success, the profound adoption and momentum of our community. Without that collaboration, pieces start to fragment and move apart. So technical deliverables and compatibility and verification are two of our most important ways that we support this community. Amplifying through visibility, events, analyst relations, and original content, we also seek to amplify the story, amplify the momentum across industries and around the world. Learning and talent, continuing to build talent around the world on RISC-V. This comes in the flavor of online training courses, dedicated training partners, as well as alliances that we have across and among universities to share curriculum. And importantly, we help people find jobs. So whether those are internships or full-time roles, we have jobs available in RISC-V around the world within the community. Advocacy and alliances. We work across different orgs to find the best sets of and collaboration on building blocks for your solutions, as well as bring out advocacy around the world through our ambassadors and marketplace exchange. Showcase time for all the amazing RISC-V solutions that we have in the community. We have a lot of work going on. Our technical deliverables and our roadmap is on fire. In fact, we have 10 specifications that are going to ratification right now. This is an incredible rate and pace, and purely based on the collaboration and the contributions of the community. This is a community-driven effort, and we wouldn't be here without the contributions of time, talent, energy, and code. This industry adoption is translating into special interest groups, such as I mentioned on Android, automotive, security, HPC, AI. We are keen to cultivate those synergies as we build out ideal stacks for various industries. Our technical programs range from cultivating platforms and profiles for compatibility to engaging contributions through RISC-V labs and RISC-V development partners. And then we are keen to seeding the industry, early adopters, students, as well as operating systems and other organizations with RISC-V development boards, so you can get started on your journey. It is that entire ecosystem. We are built on a community and with many different stakeholders. So thank you. I appreciate the time that you've taken. I hope that you will engage in RISC-V and realize that that shared investment, that shared strategic value of cultivating a solution on RISC-V has a durable long-term advantage. It is reduced risk because you're not relying on one particular party. It has opportunity for collaboration, for supply chain. It has incredible opportunity for growth. Think about RISC-V when you look at that greenfield space, when you look at that next project, when you look at finding differentiation in your existing portfolio of projects. Think about RISC-V and how you can leverage that for your success. And together, the RISC-V International is here to support your success. I hope you'll follow us. I hope you'll engage with us and give us your feedback. We appreciate and grow and build and become better together with you. It is that collaboration that has reformed the most important time in our computing history, and that is the era of open computing. We're here with it. We are here to grow and build with you. Thank you for joining me, and I appreciate your time.
Wow. Calista, I don't know if you can hear us.
I'm still here. I'm
Good.
still here. I'm sorry. I was driving the car and now I'm not driving the car, but somehow logged into a different computer that doesn't have my picture on it. My apologies.
Oh, no, it's quite fine. You know, that was a very impressive, to pull this whole ecosystem together. I mean, that's a lot of work. I can imagine how many different groups of people you have to talk to on a daily basis to do that.
Well, if you want to know, we have about 60 different work groups. So there's a lot of excitement going on inside of RISC-V. We've got thousands of folks who are members, 10,000s of folks who are engaged. So we are fairly busy, and it's a really exciting and passionate place to be.
Great. Yeah. So a couple of things. One is that you mentioned the software part of the ecosystem growing extremely fast and all that. Not just in the recent past, my understanding is that software engineering talent pool for the RISC-V ecosystem, because it's growing, it's relatively new. My understanding is that it's still relatively challenging to hire software firmware talents who are familiar with that ecosystem, say compared to the talents with, say, ARM and x86. Is that still the case? And if so, do you see that change in the near future?
Well, I have really good news for you. The RISC architecture has been around since the mid-'80s. So nearly all students who have gone through computer engineering types of programs have heard of RISC architecture. And the challenge is then understanding capabilities specific in RISC-V or RISC architectures that are different from the other architectures they have been working on, to know whether or not porting to RISC-V, supporting software on RISC-V makes sense for them. So there's a little bit of a chicken and an egg, if we are going to port first and see the market later, or if we were waiting for the market to come and then port and support. So there is that challenge, but that is a bit more of the challenge than the talent side. On the talent side of the house, we are, we have a Learn program that has both training partners that corporations can hire to educate hundreds of engineers or tens of engineers at a time. We have online learning. Nearly 10,000 people have signed up for some online learning that we launched in the second quarter of this year. We have many organizations who are offering specific RISC-V training as well. So we have gone out the gate very quickly on that. And I will say that recently I've had some data center folks come back to me and say, you know what? It's actually really easy to move on to RISC-V. And I said, great, what do you mean by that? They said a small handful of days in some cases and a couple of weeks in our worst cases. So it is very possible. It is very much within reach. And, there's a lot of work to be done. right? I mean, we are working with Alibaba, who has been a true leader for us in the Android community, and they have ported Android to RISC-V very successfully. And, so we're looking at that as example number one to really start to bridge into some of those other spaces. We have all the major operating systems on RISC-V, of Linux operating systems, Red Hat, Ubuntu, SUSE. So, the software ecosystem is not dependent necessarily on discrete skills or unique skills to RISC-V. These are skills they all have already, and that's good news.
Wow. Just a few weeks I can pick up through your tutorials. Now I'm interested.
Take it and run.
All right. Very good. Very good. That's good to know. A good portion of the RISC-V projects, right, like you mentioned in one of your slides, initially it was in the IoT and the consumer device space. And we know you used to be in the leadership position related to the IBM Z systems, or that's the IBM mainframe, if I'm not mistaken.
Yep.
So how soon? And you did mention like Alibaba and Amazon. They are pushing, leveraging RISC-V even in the data center environment. But how do you see RISC-V based SoCs compete in the high end of data center segments for the hyperscalers? And realistically, how soon is that going to happen in a more broader base?
It's already happening. When I look at the spectrum of folks, placing bets, deepening investments, making strategic decisions to take RISC-V all the way through, it's already happening. From Western Digital in storage and Seagate in storage to Google just leveled up from regular strategic member to start to bring more of their data center folks in as a premier member, to Alibaba with nearly a full roadmap of RISC-V going on, and even NVIDIA, who has been shipping RISC-V with their GPUs for years now. This train has already left the station. This is already happening. I will say, in that spectrum of folks who are coming to RISC-V, we have hundreds of entrepreneurs and other smaller startups who are basing their business on RISC-V because they don't have to worry about all the investments their company has made on other architectures because they don't have that history. And so that's an exciting time for entrepreneurs. In fact, we have one board member who is a VC firm in China, and that's all they do. They make investments in RISC-V based companies. And we see that happening in Silicon Valley in California, as well as in China, starting to see that happen even in Europe. So those are exciting times, and those small companies are all RISC-V to begin with. Now, the multinationals, they've got a tougher hill to climb. I know that at IBM, I never got to go to the boss and say, I've got some speeds and feeds, and we need to apply some money to that. They would laugh at me. They said, no, you need to show me the business case, the revenue, the cost savings, the risk aversion, all the things that go into a business strategy decision. And so for the multinationals, they are more often putting a toe in the water with a microcontroller rather than a primary processing unit. So that is the path that many are taking, but it is opening the door, and it does open the opportunity more for future generations, future designs to bring RISC-V into their primary processing as well. And those are things that are being actively explored with many others. And we're talking to all of them, all the hyperscalers, all the, the scale out data centers, the, very similar crowd with the HPC.
I personally have a number of customers, and Caspa, among the audience today, there are many people that's involved in startups that's RISC-V based. Yeah. So more power to them, to all of us. That's great.
Yes.
Yeah, so in the introduction, we understand that you went to Michigan, Northwestern, the top Big Ten schools. I don't know if you're a big football fan in this college football season. So who do you think is going to be the Big Ten champion this year?
Oh,
Now, just to remind you, I went to Ohio State.
So it's a really good question. You know, I did my undergrad at Northwestern, and at that time, a long, long time ago, there wasn't a whole lot of sports scene going on there. So things were pretty quiet. I think their luck came later. And then I went to grad school at Michigan, and I truly began to understand what a fanatical, crazy sports culture could be at a university. And this was while I'm in grad school. So I may have switched, maybe next time I would have switched that around for that fun. But I do think that Michigan's got a solid chance.
Here we go. We'll find out in a month or two.
Yep, there we go.
That's great. Well, thank you so much, Calista. As you know, and I know you start working on it already, you know, we have quite a few people just like me, very, interested in this topic, and they're posting questions in the chat room. So if you still have a few more minutes, feel free to entertain some of those questions.
Absolutely. I'd be happy to add to the chat room here.